Hello, everyone. My name is Ben Bigelow, and I'll be the instructor tonight. Thank you all for taking the time out of your day to learn a little bit of Python. I think Python is really cool, and I hope that you'll find it pretty cool as well. I'll post some links in the chat so that you can get to the syllabus and the page we'll be using for programming as well in a minute. I just want to give some background first on Python in general before I start sharing my screen and we start delving into the programming. So as some of you might know or may have heard, and that might be why you signed up for this course, Python is a pretty popular high-level scripting language, and you can use it for general purpose programming. There are some notable organizations that use Python, and these include Google, Wikipedia, Yahoo, CERN, and NASA as well. The two companies that I've worked for in my career have both been Python shops as well. It's a very well-developed language with lots of uses. You can use Python for anything from data analysis or machine learning, which is pretty popular right now. And you can do things like web development, so developing websites or game development. Pretty much if you can think of something that you want to do, you can probably do it in Python. The sky is really the limit. So in our course tonight, we're going to start out with some simple concepts and work through them. And we'll work towards building an interactive rock, paper, scissors game through the course. If you have detailed questions about how certain functions or certain methods or certain things in Python work, I'd advise you to consult the documentation, and I'll post a link in the chat in a minute, because that will have pretty extensive documentation and detail on how anything works. It's probably much more detailed than what I can give you. So I will share my screen in 1 minute. I'll just share the links that you'll need in case you don't have them.
Just so you all know, Ben's putting them in the chat. If you have trouble finding that, let us know, but that's where they are.
Okay, so as Sarah mentioned, I've put 3 links in the chat box, so you can find the links there. The first one is the site we'll be using to write our Python code tonight. It's called Replit. The second one is the course syllabus that we'll be working through. And the last link is the Python documentation. So with that, I will share my screen. So if you're having trouble seeing the screen, please post something in the chat or in the Q&A, and I'll look for it and we'll see if we can debug. But right now you should be seeing the syllabus, and over here is the Replit site that we'll be using for coding tonight. So just to run through what this site looks like and what everything is, this right here is an editor window. So this is where we can write our Python. On the right side here, we have a terminal or command line. So I can write things here and it'll execute it, and you can test things this way. So you can use it like a calculator, for example, if you want. And I'll do stuff like that. And you get the immediate feedback as opposed to in here where we'll be writing slightly longer, more extensive scripts rather than just kind of testing single lines of code. And then over here, less important, this is your file structure for your directory in your project. And there are some other things that we won't get into, like the version control and the packages, really. And then if you want to run your code, you can just click run. There's nothing in there, so that nothing will happen when we do that. Okay. And the nice thing about Replit is that it comes with syntax highlighting. So if I write some Python there, it'll start highlighting things with some colors that just makes it easier to read and understand. Okay, so for our first script, we're going to type something in the scripting window, in the editing window here. So we're going to type print hello world. And this will be our first line of Python. So before you click run and run this code and see what happens, let's think about what we think will happen. So what do we think will happen when we click run? What will we see on the screen? And so we can click it, see what happens. So over here, we got something out. It says hello world in our terminal, which is what you might have expected to see. And this is where you can give yourself a little pat on the back because you've just run your first program. So this is your first full-blown Python program. This is also the first example that we'll see of what's called a function. Functions in Python can usually be recognized by the parentheses around them. So here, if you mouse over it, at least in my browser, you can actually get some help text as well to see what the function does. So this tells us that the print function prints the values to a stream or to standard output, which is just the terminal here. And there are some other arguments that you can use that we won't get into now. But that's our first function. So what print does is it takes the text inside the parentheses and displays it on the console. Displaying information to the console is one way of many of giving information to a user who's using your program or your script. It's also useful because you can see what your code is doing at various steps in the program. Now, this text, hello world, is an example of a string data type. Python has lots of different data types, and we'll go through some of those tonight. You can usually identify strings in Python by the single quotes. So we can say this is a string, or actually let's do it in here. So we'll say var this is a string. You can also do this with double quotes. This is a string. Or if you're writing a program and for some reason you need to span multiple lines, you can use triple quotes. So now I can write a string across multiple lines. So one of the things that you might want to think about is whether print has to take in a string data type or whether it can take other inputs as well. That's a little bit of a brain teaser, just something to think about. The one thing that you will want to watch out for in your quotes is what's called escaping quotes. So for example, if I type var3 here and I'll put an apostrophe somewhere, this will give you a failure, invalid syntax, because you got a bad quote there. So if you want to do that, what you can do is you can put it in double quotes like that. That's okay. Or you can, I think you can escape. Yeah. So in the first instance, you can use double quotes if you want to have an apostrophe or single quotes in your string. The other way you can do it is by what's called escaping the single quote character, and that's just you put a backslash in front of it. And then Python will treat this not as the end of the string. So those are the string data types. For our first exercise in using Python, I'd like you to try to change your script to have it print "Welcome to the rock, paper, scissors game." And this is an exercise that you can do on your own, but we'll be coding it interactively as well.
Hi,
So,
Ben.
yes.
Sarah, we have a question.
Okay.
How critical is capitalization and spacing?
Okay, so how critical is capitalization and spacing? So it depends a little bit on what you're talking about and what in what context it's being used. So in terms of referring to a function, Python functions are case sensitive, so you can't do, for example, print. This won't, you'll get it, and you'll get this squiggly red line there that says an error. So this has to be lowercase in order for it to work correctly. Anything in your string can be whatever case you want it to be. In terms of how you write your code, let's see, pep case. This is part of the style guide for Python. So if you want to write what's called Pythonic code, and I can look for this later, but in terms of how you write things, there are conventions around casing that you should adhere to. So here, for example, it says class name should normally use the cap words convention. So if you were to write, this is a little bit advanced, but just to answer the question, if you were to write a class, then it should be new class. You should write it like that. You shouldn't write your class new underscore class, all lowercase. That would be considered poor syntax. So good question though. Thank you. And it looks like does it impact the coding? Again, it sort of depends. If you have, so let me just do those. If you have a function, right, some function like this print function, and you want to use it, then you can't call it like that. That's not going to work. So that you'll run into an error in this program. So let's see. Yeah. So here you get name print not defined because you haven't used the proper casing. So hopefully that answers your question. And if not, feel free to ask another question as well. But back to our exercise, we're gonna look to change this to welcome. Since we're gonna build a rock, paper, scissors game, we wanna welcome the player to the game. So we're gonna type in welcome to the rock, paper, scissors game, exclamation point. If we run that, that's what we'll see on our screen right here. So we've welcomed the user to the game. So for the next section that we'll be going through, the next concept that we'll be discussing is getting user input. If we're trying to build an interactive game, we'll probably want to ask the user for some information, such as their name, and if we're playing rock, paper, scissors, we want to get their choice of whether they're picking rock, paper, or scissors. So we'll expand this a little bit now. So we'll write another print statement, or I guess we've got that one already. We want to get the user input. So we'll say player input, what's your name, space. And you can see here we put double quotes because we've got that single quote here that we don't want to deal with. And then after this, we'll print welcome player. So I'll click run, but before I click run, let's think about what might happen here when I run this script. So we're welcoming the player, welcome to the rock, paper, scissors game, and we're asking them your name. So we can click Ben. And it says, welcome, Ben. So that's kind of nice. You've asked the user for something and you've gotten something back. Here we see another example of a function in Python, and the function in question is the input function. The input function prompts the user for an input and then stores that value as a string. And in this case, stores it as a string variable called player. A variable is a way of storing information to make it easier to access or manipulate in the future. So now anytime I want to print the player's name, I can just call the player variable as opposed to asking for the player's name over and over again. In Python, variables are assigned with the equals sign. So if I wanted to assign a numeric variable such as age, I could assign that with an equal sign and just say, 28 or 42, whatever you want it to be. Now, you might notice something funny about the last line here as well. Python 3, which is what we're using, so this is actually the, I don't think it says it. Let's see if we clear. Okay, it says it up there. We're actually using Python 3.8.2. Python version 2.7, was end of lifed this year, which means it will be no longer supported. If you're thinking of programming some sort of application, I would advise you not to use Python 2 since it'll no longer be supported. Everything should be done in Python 3 now. But Python 3 introduced a method of string formatting, so putting variables into strings, called F formatting. So basically, all we have to do is put an F in front of the string, and then we can reference variables. So if I were to add that age variable and then put something in here, I could just use the age variable. You are age. You are age years old. So now if I run this, put in my name again, it'll print out that variable value. So very useful. And just to give you a sense of why it's a little nicer than what we had before, there's a few other ways of doing this. So we can say print welcome player, no F at the beginning, and then use the format function and say player is equal to player. So format will see the player in there, and then that relates to the player variable here, and it will replace that. Or you can use a %sign formatting. So you can say welcome S. And what will happen here is Python will unpack this variable and stick it where the %s is. And the %s stands for string. So if I run this, type in my name again, it prints out all the same. So each one of these works the same, but the I personally find the F string formatting much easier to read than the other ones. All right, so for our next challenge, our next exercise, we're going to modify the script so that it prompts the user for a role. In other words, it prompts the user for either rock, paper, or scissors. So what we can do is put that in a variable called role. We'll say role is input. We'll use the input function again. Choose your role, rock, paper, scissors. And we can print the role that they've chosen. So now if I run this, I give it my name, choose a role, and it tells me the what I've chosen to pick for my role. So again, if you have any questions, if anything is unclear so far, feel free to ask a question in the Q&A or the chat, and we'll try to get to it. But if not, we'll keep going. So the next topic that we're going to talk about is logical operators. So our script looks like this, kind of like what we just wrote. And we've asked the user for input that we might want to use later on. But you run into this question of whether or not the input is valid, whether it's good. So far, there's nothing in here that makes me have to pick rock, paper, or scissors. I could write lizard, or I could put 5 in there. And that obviously would not make much sense unless you're playing a very strange game of rock, paper, scissors. So by using logical operators, what are called logical operators, we can validate that we can use what the user entered. And there's a few different logical operators. So the first one is the double equal sign, and we'll test it out on the terminal here. So I'm just going to assign some numbers to some variables. So we'll make A a value of 5, we'll make B a value of 5, we'll make C a value of 6. And you can test equality in Python with a double equal sign. So I can say, is A equals B? And that's true because A is 5 and B is 5. Now, maybe you want to check, is B equals C? And that'll give you a false. So this is not true because B is 5, C is 6. So they're not equal. So the double equal sign checks equality. There are a few other equal ones or other useful logical operators. So one of them is exclamation point equals, which is not equals. So A not equals to B. That's false because A is equal to B. And we check B not equal to C. That'll be true because B is not equal to C. 5 is not equal to 6. So that's not equals. We've got less than it equals. That's true. We've got greater than or equals, also true. And then we've just got basic less than, basic greater than. There's also the not operator, which inverts your logical condition. So we've got A equals B. That's true. And now you can flip it by saying not A equals B. So then that becomes false. All right. So let's go back to our script and we'll change it so that we're checking the user input. So we'll ask the user for something, and then we're going to say print whether their role is equal to rock. And I'll just copy this a few times. Let's see. See if it's equal to paper. See if it's equal to scissors. I'll run this, enter my name, enter my role, say rock. Right, it's got false, 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 because it wasn't matching any of these. Now, it's a little inconvenient to check things over multiple lines, so what we can do is start to combine things using a few other logical operators, and the first one of interest is the OR operator. So we can combine this into one line by using the ORs. Now, if I run this, say rock, Now you've got it in one line, it checks whether or not it's true, gives you one answer. So the way the OR works is that it'll check the conditions on both sides of it. And so if you have 3, it'll check all 3, or 2 ORs, it'll check all 3 conditions. And if any one of the conditions is true, the entire thing will be true. So as long as your roll is either rock, paper, or scissors, this will be true. If it's not, then it will evaluate to false. The counterpart to OR is the AND operator. And the way the AND operator works is somewhat the inverse of the OR. In order for this whole thing to evaluate to true, every one of these has to be true. Obviously, in this case, it won't make sense, but we can run it anyway. So we get true because it's one of these 3, but we get false here because it's not all of these 3. So again, the AND operator is useful in some cases. I don't think we need to use it here. So those are the logical operators that you can use to compare, compare values. And they're not always super useful on their own, but where they are quite useful is when you combine the logical operators with what's called a conditional statement. A conditional statement is also sometimes called an if-else clause. And what that does is it allows us to change the behavior of our program based on a logical condition. So what we can do here is we can say, check if the roll is rock, or if the roll is paper, or if the roll is scissors. If it is one of those, we can print the input is good. So we can accept it, we can move on in our program. Else, we can print input is not good. So now if we run this, it'll be a little bit more sophisticated. We'll say rock, input is not good because we got a capital R, not a lowercase r. But the good part of this is that it's checking our input. So just as an exercise, one of the things that we could do is we could change this. Right now, this is using ORs and double equal signs. We can also change this to use ands and not equals. It's pretty straightforward, but it does the same thing. So now instead of checking whether the player's role is any of those 3, it'll check whether it's none of those 3. And if it's none of those 3, then it'll be not good. And we should switch this. Looks like I'm getting a connection error, so I'll have to reload. But as you can see, the output is the same. So this conditional is the same as the previous conditional that we wrote. Great, so far we've made some good progress. We've welcomed the player to the game, we've asked for their name and their role, and we've checked whether the input is acceptable. Next, I'm going to talk about a new data type called a list. So in Python, lists are very powerful data structure. A list is an ordered and changeable group of data that's usually denoted by square brackets. So I can make an example list here. So if I did that, so that's a open square bracket, close square bracket. That's just an empty list. But we can make another list and you can put anything in it. So we'll put a few different things in there. As you can see, it can be a mixed list. It can be a list with just one type of object, but you just put it in square brackets. The other way that you do it is you can just type list, and that'll make a list object for you. But usually, more often than not, you see people using the square brackets rather than calling list. So we've got this list data structure, and we've got variables. So one of the things that it might be good to do is to store our role options in a list. So our role options can either be rock, paper, or scissors. And actually, if you really want to be clean about it, Python style guidelines say that you should put constants as all uppercase. So we'll make that uppercase since this is not going to change. We're always only going to be doing rock, paper, scissors. So now, let me just type this out in here so that we can work with it. So you might be wondering, okay, we've got this list. How do we get things out of it? Or how do we check what things are? So if you're looking to get individual items on the list, you'll do what's called indexing. And lists in Python are indexed using integers starting with 0. So if I did role options 0, I'd get the first item in the list, which is rock. If I were to do role options 1, that would get me the second one, paper, and so on and so forth. So now we've got these role options up here. We can use that down here to give the player a choice. So what I'll do is I'll use this f-string formatting, and we'll do something a little slick in here as well. So what we'll do is we'll say, let's see, slash, excuse me for 1 second, just typing this out again. Okay. All right, so we've changed how we get this input. We've changed the string here, but it still prints out the same. So what we did is we took advantage of the f-string formatting and our new variable to just say we're going to combine each one of these items in the list with a /. So what .join does is it combines the objects in this list with the string that you specified here. So if I were to add something in here, it would still just tag that on to the end with a \. So that's lists. And what lists bring us to is that there's another operator that we can use to clean this up even more, which is the in operator. So we can say role in role options. So if the role is in this list of role options here, then you've got good input. Otherwise, it's not good input. So if we run this, we still get back to the same place. And as you can probably tell, this is a lot cleaner. I mean, it reads a lot easier too. You're just checking to see if the role is in the role options that you defined up here. So like you can probably see, it's a lot cleaner to read. Great. Awesome. Moving right along. And like I said, if you've got any questions, feel free to post them to the Q&A. So now we're going to take a little bit of a detour to talk about errors in Python. So we're going to try something out here on the command line. So we're going to print total, and we're going to add 10. And so what I'd like you to do is think about what's going to happen now. So you probably have an intuitive idea of what will happen when we hit enter, and let's check to see if it matches. So if you thought you were going to get total 10, this might be a little bit of a surprise. Python actually throws an error. Error messages in Python can be very helpful for determining what's going wrong in your code. In the message above, we see that the error message tells us the line where the error occurred, which in this case is line 1 because we were just doing it from the command line. And it gives you a general description of the error as well. So in this case, the error we're running into is that we can only concatenate string and string objects. We can't concatenate string and integer objects. So if I typed, let's see. So if we look at what 10 is, it's an integer object. And if I look at type of total, it's a string object. So we can't add those two together. So if we want to avoid that error, we'd have to do total plus string 10. Oops. There we go. And so you wrap the 10 in a string, and now you don't get that error anymore. But when you're first starting out with programming, you'll likely make a lot of small mistakes. So understanding error messages and how to use them to help fix your code is an important skill to have. So that's what Python error messages look like. All right, back to our rock, paper, scissors game. So far, it's looking pretty good. So we've welcomed the user to the game. We've asked for their name and their role, and then we've checked whether the input is valid. So if they're playing rock, paper, scissors, they're playing against the computer, and we'll probably want to generate the computer's role next. To make things interesting, we'll want the role to be random. Thankfully, Python has a built-in module called random for working with random numbers. A module in Python is a set of similar functions or objects generally used for similar or related purposes. So if we want to import the random module at the beginning of our script, we can just add the following line. And that does it. Now we can use anything that's in the random module. And you can use this the same way if there's some module of interest to you, like I mentioned at the beginning, that's deep learning or machine learning or web development. All you have to do is import it at the beginning of your script. Okay, so as we learned, we can index lists in Python with integers, for example, 0 or 1 or 100, however long the list is. What we could do is we could use that indexing approach to pick the computer's role. The random module has a randint function that generates a random integer, and that's what we'll use for this purpose. So we've got the user's role. And now we want to generate the computer's role. So I'll say random.randint 0, 2. And then we'll make another variable called computer role. which will be role options, rand pick. And I'll take a brief detour here to talk about comments. So if you want to make a comment in Python, you just put the hash sign, so Shift 3, or the pound sign, depending on what you call it. And then you can add comments to your code that make things easier to read. So we'll just type out some comments here to make our program a little bit easier to read. All right, so now we've added comments to our program, and it's a little bit easier to read. So if you're not familiar to Python, at least the comments will give you something to go off of in case you're confused or may not understand what certain functions or certain lines of code do. So this is one way of picking the computer's role. And as with lots of stuff in programming, there is more than one way to skin a cat. So the random module actually has a nice choice function that allows you to pick a random item from a list. So what we'll do is we'll delete this. So you can use the random integer, but we don't have to do that. And we'll just do, say, computer role as a variable. And then we'll just do random.choice role options. And then to see how things work, we'll print the computer role. And now if I run this, ask for a name, pick rock, and the computer got scissors. So that's how that works. And as I mentioned before, if you are interested in these modules and what goes on, you could say, you could go check out the documentation. Once I find it, here we go. Right, so this is the documentation for the random module. And if we just type randint, that'll come down there. So it returns a random integer. And if I were to find choice, so returns a random element from a non-empty sequence, which is what we wanted to do here. Excellent. Okay. So now that we've got the user's role and the computer's role, we want to compare the two to see who wins, right? That's the whole point of rock, paper, scissors is scissor beats paper, paper beats rock, rock beats scissors, and so on and so forth. The first step to building those rules is constructing what's called a dictionary. A dictionary is another built-in Python data type. A dictionary is similar to a list since it's unordered and changeable, but dictionaries also have formal indexes or keys. You can think of dictionaries as key value pairs. Dictionaries, similar to the way you recognize lists by the square brackets, you recognize a dictionary in Python with curly brackets. So if I were to make an empty dictionary like that, it would say this is a dictionary object. So up here, we're going to add a dictionary. And we'll say we want rock to beat scissors. Rock we want paper to beat rock. So paper. And then we want scissors to beat paper. And so that's our dictionary. Unlike lists, which you can access with integer indexes, so if I were to make a list here, 0, actually, let's say 1, 2, 3, 5, and then if I were to go 2, that would be 3. You can't access items in a dictionary using indexes. Instead, what you can use is you can use their keys. So if I were to make a new dictionary here, we'll just say first name, I'll say is Ben, course, say intro Python. That's a dictionary. If I wanted to get the first name out of there, I could say first name. So this is why it's called a key value pair sometimes, or a key value store, is you search for the key and it'll give you the value of that key. So if I wanted to get the course, then I just do the same thing and it'd tell me there. So now what we might want to do is add some rules, add these rules and let the user know about the rules. So say here are the rules. And we'll say 1, 2, 3, 4. Say rock beats. And then we'll say, and the string there. We'll say rules. And we'll look for it by string. So rock beats whatever rules rock is. So in this case, it's scissors. We'll just copy that a couple times for the rest of them. We'll say paper and scissors, and then just do the same thing here. So now if I run this, we get a nice little summary of the rules here, right? So we know rock beats scissors, paper beats rock, scissors beats paper. And then we can go in and do all of that stuff. Great. Excellent. Moving right along. So we've just talked about dictionaries and how they can be used, and we integrated the dictionary into our program here to store the rules of what beats what. Next, we're going to talk about another fundamental programming structure, and this is a general programming concept across lots of languages, so it's a good thing to know about. In programming, there's a principle for coding called DRY, or DRY, which stands for don't repeat yourself. So anytime you find yourself copying and pasting code or writing the same line of code over and over again, it's probably a good indicator that you should clean up your coding a little bit, move it into a variable or something else that can be reused over and over again. If you look at the last few lines of code that we wrote in the previous section, you should notice that there's a lot of repetition. So here, for example, we're basically repeating the same line over and over again. There's no real need to write this print statement multiple times. So how can we get rid of this and make our code cleaner and simpler. One of the ways we could do that is by using the concept of a loop. So a loop in programming is just a way of doing the same operation over and over again for a set number of times, or for all of the items in a particular object. So if we wanted to do everything over each item in this list, for example, or until a certain condition is met. So that's something called a while loop. If you want to run something as long as a condition is true, you could write a while loop. Those are all examples of loops. A for loop in Python executes steps a set number of times, a finite number of times. And you can write for loops with the following syntax that I'll just put up here real quick. So for I in range 1 through 11, do something here. Pass. So this is what a for loop looks like. This variable, sometimes people get hung up on this, but you can call this whatever you want. I is usually used if you're looping through numbers, if there's some sort of indexing. If you've got a list that has a certain concept, right? Like it's a list of names or it's a list of files or documents, you might name it something more descriptive, like you might say for name in list of names, or for file in list of files. But it's really context dependent. And then for everything in this range, so range 1 to 11 will give you the numbers 1 through 10. It stops at 11. It'll go through this loop 10 times and do something. So if I do this out here, for I in range 1, 11, and then we can do print I. Then you can see it's pretty straightforward. It just prints out the numbers 1 through 10. So not terribly exciting in that instance, but depending on what you need it for, it can be very useful. So what we'll do is we will rewrite this section here to use our dictionary and to use a for loop. So we'll get rid of that in our main program. And we'll get rid of this as well. And we'll just say, and we can do this a few different ways. So I'll actually write this out. We'll use keys. So for key in rules.keys. Print f for key beats rules key. So I'll write this a few different ways and then we'll go through what each one of them is doing. So next we'll use we'll unpack the dictionary using items. So for key, comma value in rules.items. I'll just do this. For key, and then just make this value. And then we can do this using the roles list as well. So for role in role options, print the role. Print the role beats rules role. So this all does the same thing. So now if I run this, you get the rules there. So 3 times the same thing, but all of these are the same. So now let's go through and try to understand what's going on here. So we've got our dictionary of the rules, and we're calling this function keys on it. So what that does is it returns an object that has all the keys for the rules dictionary. So in this case, what it will return is something with rock, paper, and scissors. And then what we can do is we can just put that key variable that we define there, every time through the loop, it will use that key, put it in there, and then we can use that key to go back to the dictionary and pull out what the value is, right? This is how we indexed the dictionary as we learned. So in the first loop, this will be rock, and it'll print out rock beats, and then we'll go to the dictionary, ask for the rock, use the rock key to find the value scissors. So rock beats scissors. That's how that works. Items is a little bit easier to understand. So what items does is it unpacks this into key value pairs, which is why we've got that there. We've got key and the value variables. So now instead of having to call the dictionary again, we can just say key beats value. So rock is the key, scissors is the value. Paper is the key, rock is the value. We'll loop through that list like that. And the last option, not quite as clean, is you can go back to these this role options list as well, because you can loop through a list as well as a dictionary. And so that'll just pull out the string in each index, and then you'll refer back to the dictionary as well. All right, so that's for loops. So I'm just going to keep the one with items, since I think it's a little bit cleaner. And I'm just going to look up a function real quick because I think it's there's a way of doing this and I can't quite remember what it is. Let's see. Stop. So we'll A equals. Okay, yeah, that's what it is. So I'll just add this capitalize to make it a little bit nicer to read. So not capitalize. So now if I run that, you can see we get the kind of nice there. And actually we can remove it from the values because that is not proper sentence structure. All right, so that's for loops. If you have any questions on for loops or loops in general, feel free to ask them in the Q&A. All right. In the next bit, we'll be talking about functions, which are, again, much like for loops, a pretty important and fundamental programming concept to understand across languages, regardless of the language that you choose to program in. We've seen a few examples of functions in the course so far. If you recall, we've got the print function here, pretty obvious. We've also got the input function, where you ask a user for input. And we've got the random.choice option, or random.choice function down here, which selects a random value from a given list. So we've got all those functions that we've used, but one of the main benefits of programming is the ability to write your own functions. So way back when, in the Stone Age, random.choice as a function did not exist, but somebody wrote it because they needed it to do something. And that's something that you can do as well. So anytime you need to do something custom that there might not be a function for, you can write your own function. And the syntax for functions is as follows. So we'll make an example function down here. It won't do anything. You can say def my function input 1 then now in between, when you've got a function and you've got these triple quotes, triple double quotes there, that's what's called a docstring or help text. It's the text that displays what your function does. So like if I go up here and go over input, it says something. And what it says on my screen is what's been written in the help text for that function. So if I write this here, this is where I say what the function does. And then you can write stuff in here for function to do. In this case, I'll just pass. Pass is just kind of like a nothing in Python. It means don't do anything. So this is what a function looks like. You've got the def, the function name, and some sort of input value, possibly. And then the help text, let's see if that works in here. So yeah, see, so there we go. So the help text that we wrote in here actually gives us a hint as to what the function does. That'll pop up in Replit as a nice help for what a function might do. A good way or a good reason to use a function would be comparing the roles of the user and the computer, because that's something that we want to be able to repeat over and over again, and it's a little bit custom. So what I'll do is I'll define a function now, compare roles. We'll say role 1 and role 2. We'll add the help text in a minute. So basically all this is going to do is compare these things. So if rules, so I'll write this out and then we can talk about what it does. Elif role 1 is equal to role 2, then the outcome will be a tie. Else, the outcome is lose. And then we'll return the outcome. So let's just go through what this does real quick. So we've got a conditional statement, which is something that we've discussed before. And we've got the one wrinkle is this elif. So all the elif is a way of adding multiple conditions to an if-else clause. So if this, then do that. Else, if this, then do that. Else, and then this will be the last thing that you try. So now let's look at the logical conditions that we're working with here. So we're going to check role 1, which will be the first role that comes in, to see if role 1 beats role 2. So we'll look at the rules for role 1 and compare it to role 2. So if we go back up to, so let's say that role 1 is rock. So rules of rock is scissors. So it'll check if scissors is equal to role 2. So let's say scissors is equal to scissors. That means that you've won, right? You've rolled a rock, the other person rolled scissors, so you've won. If role 1 is equal to role 2, I rolled rock and the computer rolled rock, then it's a tie. Then nobody wins, right? We both got the same roll. If it's not a tie and it's not a win, then it has to be a loss. So the outcome will be a lose. And then the return, then you'll just return the outcome. So what that means is this will give the outcome back from the function in a way so that we can use it in a variable, for example. Awesome. And now to just clean it up a little bit, we can add some help text. So we'll say this function compares roll 1 to roll 2 to see which one wins. And then to be a good steward of your code and to write good documentation, you could add notes on the inputs. So we've got an input of roll 1 and an input of roll 2. Just say what these are. Give a description of what these parameters are. So we'll say roll 2 is the second roll 1 is the first roll, and then we'll describe what it returns. So this gives back a string indicating whether roll 1 wins, loses, or ties with roll 2. So that's that function. And I'm just going to copy this and put it at the top so that we can use it. There we go. So that's our function. If you have any questions about functions, I'll be happy to answer that via the Q&A, so feel free to post there. And the exercise that I'm going to run through now is writing a function to print the game header, and then we can move our gameplay into a function as well. So we've got our compare roles function. I'm going to write another function called print header, and this one won't take in anything. So I'll let's see. I'll give it a one-line doc string. So this function prints the game header. And we just say, we'll just copy this and put it up here. And make sure it's properly indented. So that will print the header. So we've got a function to print the header, a function to compare the roles. And now we can write another function to encapsulate our gameplay. So it'll just take in a player variable. We can, let's see, take this, put it up there. So we'll welcome the player, and then let's play 5 games. So we'll do, I'll store this in a variable just for fun. So num games equals 5. And we'll comment this to say this is the number of games to play. Options for user to pick, and rules of the game. So we want to play 5 games. So we'll use a for loop again. So for I in range 1 through num, then we'll use that num game variables, add 1, because remember the range function stops 1 before your end. So if we just did range 1, let's do it in here, range 1 through 5, that would just go up to 4. So you have to add the 1 so that the range works correctly. So we're going to print the name of the round. So we'll say, we'll use our F string formatting again and make sure the string is closed there. We'll ask the player to choose their role, so we can cut that, put it up here. Then we can get the computer role. And we'll check the input. And then we'll get the outcome. So check to see who wins. Check to see who wins. And we'll say the outcome is compare roles. Role 1 will be role, which is the user role. And actually, let's rename this to player role. Player role. And then we'll just copy that, replace it there, place it there, player role, and then we'll compare that to computer role. And then we'll just print some statements to show the state of the game. Print state of the game. So we'll print enter. So we'll print what the player threw using the F strings again. So player through player role. We'll print, let's see, the computer through the computer role. And then we'll print what the outcome is. So we'll say F, let's see, the player, and then we'll say outcome. Yes. And that's because we made this, where is it? Win, tie, lose. So if you want to be grammatically correct, you can add the S on there. And then we'll add a print statement that just prints a new line and gives us some space. And now let's get out of the for loop. So we indented backwards 1, so we're out of the for loop. And we'll just say ending the game, thanks for playing, once I spell that correctly. And then down here, we can just say, okay, so print the header using our print header function, ask for the user's name, and then start the game. All right, so we've got our code, and now let's see if it works. Click run. Oh, missing a parentheses there. Now let's run this. Okay, so welcome to the rock, paper, scissors game. Here are the rules. Rock beats scissors, paper beats rock, scissors beat paper. Name, I'll put in my name. Okay, so round 1, I'll pick rock. So I threw rock, the computer threw paper, I lost. Major bummer. So sad that I'm losing to a computer. So for the next round, I'll choose paper. Lost again, it's really not my night. Computer threw scissors. Let's try scissors. Try to outsmart the computer here. Again, lost again. Major bummer. Round 4, I'll go back to paper. Tied with the computer. So that shows you what happens when we get a tie there. And I'll go back to rock, see if maybe I win one. All right, so I won one. So I threw a rock, the computer threw scissors, and I win. And then we've gone through 5 rounds, and so the game ends, and I get thanked for playing. All right. So if you followed along up to this point, I'd like to say congratulations to you because you've written a complete program that plays several games of rock, paper, scissors with a user. This might seem simple. It might seem like a simple game, but you should really appreciate all the things that we went through and that we learned tonight in building this game. So we learned about importing modules, data structures like lists and dictionaries, data types. I didn't go too much into data types, but we learned a little bit about different data types. Functions, both built-in functions like print, as well as defining your own functions like we did here. Conditional statements, for loops, all sorts of stuff. We learned a lot of good stuff tonight. So give yourselves a pat on the back for building that program. So now that you've got this program, there are some ways that you could improve it. If you're interested in doing this, there's tons of documentation on how you could do that. One way is you could add error handling, what's called error handling, to make sure that the user input is a valid choice. It's a different way of handling or validating input compared to using if-else clauses. You could change the program to let the player pick the number of games they want to play. So maybe I'm sort of mad that I lost 3 of the 5 games that I played and I want to play best of 7 because I'm a sore loser. You could modify the script so that you can pick the number of games that you want to play. You could also modify it to let the player type quit to quit the game. So maybe, like I said, I'm a sore loser and I don't want to lose against a computer, so I'll just quit the game before going through all my rounds. And another way that you might want to improve it is adding a scoreboard to keep track of who won how many games. So the way that would work is you could store that, and then at the end of each round, you could say, Ben 0, computer 1, Ben 0, computer 2, so on and so forth, and then maybe print it at the end of the game. So if you're interested in doing that, there's tons of documentation online or tutorials or other ways of learning how to do that. Since we're almost at time for the class, I'll end by saying thanks for coming out tonight and for staying on. You could have been anywhere in the world and you chose to be here with us, so thank you for that. And I will also plug the library resources for learning Python if you're still interested in learning more Python. Like I said at the beginning, there's a huge amount that you can do. This is just one small example. The library has quite a number of books. I don't recall what all of them are, but there are some beginning Python, intro Python books that you can check out. If you're also interested, you can go to lynda.com, since the library allows patrons to use lynda.com, and there are lots of programming courses on there for Python as well. I don't think I've taken any of them personally, but I know I've seen a few on there, especially if you're interested in some of the more popular things like machine learning, data science stuff, which is hot right now. But so I'll end with that and open the floor up. If there are any Q&As, it looks like we haven't had any questions, but if there are questions that you have that you would like for me to try to answer before the end of the night, please feel free to post them in the Q&A and I can try to answer them. Thank you.
And thank you, Ben, so much for doing this class for everyone. It was really, really clear and very detailed, so I really appreciate that. I want to second Ben's endorsement of lynda.com. If you want to use the free version, you need to go through the library website and you will be prompted to put in your library card and password. The paid version is LinkedIn Learning. So just make sure if you have trouble, just shoot me an email and I can make sure we get you in there. But feel free to put in a few more any questions if you have any right last few minutes. And again, Ben, thank you so much for teaching this class for us tonight.
Yeah, you're very welcome, Sarah. Thank you for letting me teach.
All right. Well, I'm not seeing any questions, I don't think. So I think we can end it here. If you think of something later, just let me know. And we really appreciate it and enjoy the rest of your evening.